success is part variation management, and I cannot emphasize this enough. It is quite often the case, sadly, that people will sometimes take just a few parts and commit to do bin picking and then find out that it's not really quite feasible. So it's very, very important to understand the total bell curve of variation in the manufacturing process. I highly recommend that if you were to do bin picking is to actually go to the actual factory and take a lot of pictures, or have your vendors take a lot of pictures of those parts in manufacturing over, say, the course of a week, and collect hundreds if not thousands of pictures, bring them back, and make sure that the algorithms that are being designed or the actual implementation that's being done in the integration phase actually allows such variation to be possible. In the absence of such variation management, what typically happens is a few parts are used to do a test and a buy-off on a integrator's floor, and then when the solution is the robot, vision system, and all the pieces, software and PC and so forth, are brought to the plant, people tend to struggle, and that's a huge loss in confidence for the end user, as well as profit margins and credibility for the vendors. So part variation management is an absolutely critical thing to do for all parties to make sure that ultimately the variation will be manageable, it's known, it's quantified, it's measured, and there are no surprises when these systems are deployed in a factory. And I should probably mention another thing, and that's that when these demonstrations are done, it's as important to know what it will do as it's important to know what it will not do. There are sometimes exceptions to certain geometries, to certain conditions, to maybe the last 4 parts in a bin that may make bin picking difficult, and so it's usually useful to consider a compromise or see if the customer will accept, or the vendors can work with a smaller compromise which basically solves the bulk of the problem, but perhaps not the final 0.1% of the solution. Having those expectations in place is very important in order to have confidence for everybody in the end. Okay, in a retrofit situation, hundreds of unobtrusive part pictures can be taken, and this is again a little bit more on the part variation aspect, without taking any decisions, and this also protects the success of a project. Now, bin picking has a huge potential in factories, in that typically if there's a 2-shift labor cost structure, people can save the cost of labor and throughput and tooling by using bin picking. Unknown variation cases and similar mistakes create disillusionment, and they can delay in future confidence, and that's something to really avoid, because it sometimes takes years to overcome such setbacks. Finally, the third key to success is to review and benchmark through actual test the following things. The first thing to worry about is ease of use for non-technical operators. At the end of the day, a complex 3D, fairly sophisticated mathematical solution is in the hands of an operator who may have a high school degree or less, and needs to be the person who's in charge of running this operation. So ease of use is extremely important, and the technical terms that are used in the interface must be as close to English as possible and non-technical in nature. It's also very important to train operators and technicians, and also involve them in the demonstration process, in the first feasibility process, because they sometimes have very good insights about what goes wrong with parts, or some of the things that may not be obvious to engineers in the front office. And so the involvement of operators, getting their feedback and input and buy-in is also very important. A typical FMEA type of an analysis can also be done, which is commonplace in other manufacturing installations. It stands for failure mode engineering analysis, to see what is the detriment or impact if a camera is lost, or a cable is lost, or a robot is lost, and the cost and time to recover from those things. Similar analysis can be done for bin picking to minimize the risk and the typical things that go with that. So with that, I will conclude by saying that bin picking is a manufacturing solution whose time has now come. There are many examples of bin picking that are ripe for success and financial benefit to end users. The content above provides a methodology for analysis and evaluation. It also provides project management guidelines critical to protecting end user success. Thank you very much.
Well, thank you, Adil, for that presentation. And we do have a couple of questions from our attendees. Let me get right to them. The first one asks, are there any theoretical limits to solving all bin picking?
You know, that's a very good question, Jim. First of all, let's take a look at the computational aspect of bin picking. We typically have cameras that can take pictures, and we typically have robots that can move, and we've talked about some of the enablers in processing power and also computing power and lighting. But at the end of the day, to solve a typical geometry or some specific level of randomness requires computational capability. And so if we look back at some basics, like, for example, the Turing machine is a simple model of a computing device that can compute anything. It's a very simple tape that can move left to right and change bits from 0 to 1. But with that, we can solve pretty much anything. Also, in theoretical computer science, there are certain problems, and it's a little unnerving to say, but there are certain problems that have been proven to not be possible, that we know for sure through proofs that they cannot be solved. One of them is called the halting problem, which is the question of a program running and to see if the next instruction will execute or not, or will it stop at the next execution. So these types of capabilities are very important to know what can be done, what cannot be done, and also the cost of computing. Is it going to take an order of quadratic or cubic computations, or the most complex ones are called NP-complete problems. And to the best of the knowledge that we have, we do not feel that there are any theoretical limits to bin picking. What is difficult is the geometric challenge when parts are very random and there are a ton of lines and arcs and curves, and the occlusion problem, and also the entanglement problem. Consider a bin of springs that are entangled with each other. They basically form a lighting and a material handling problem and a vision problem, but there seems to be no theoretical impediment to doing bin picking. And so I believe that with a few more years of work, a lot of these problems will be solved.
All right, this next one would like to know, what are the financial benefits of using bin picking?
Well, there are quite a few. Let's take a look at them in pieces. The first benefit is the labor aspect. In a typical country of high-cost labor, such as the United States or Western Europe or Japan, the cost of labor has typically been offset by offshoring and taking such operations to countries that produce cheap labor. However, it is also known that when robots and machine vision are used in the countries of high-cost labor, that cost is really even cheaper than the cheap labor overseas. And this is quite a surprising factor or news to a lot of people. But it does mean that companies have to change the ways they have been doing things and to automate. So the first benefit is labor. Consider, for example, a 2-shift labor operation that runs for a year. Typically, in a country of high-cost labor, that's easily $100,000 per year in labor alone. A second benefit is throughput. A lot of times in bin picking, people are safe by being slow, and so they control the rate at which production is done. Even though some of the other components in the process may be automated, it is the people that are doing things slowly that hold up how many parts are made. And so throughput is another financial benefit. A third benefit of bin picking is the lack of health and injury claims and absenteeism. And finally, and most importantly, the cost of retooling to accommodate new products. When parts are typically manufactured and they change to a new product model in a year or two, quite often in the past, people have had to do tooling changes and conveyor changes and mechanical changes to accommodate new geometries. But with bin picking, you can utilize the same bins, same racks, same totes, and trays and conveyors as before, and only make the changes in software. So this stack up of costs creates a very convincing financial benefit model for bin picking. And so the key thing to then worry about is not the benefits of not the financial benefits, but the actual viability and reliability of bin picking.
Okay, and Adil, could you give us some good publications and companies for bin picking?
That's a really good question. There's a lot of interest in bin picking, and publications like, for example, Vision Systems Design. I mentioned Automation World and their 2006 article. Vision System Design did a cover story on bin picking in 2007. Automation World did one in 2006. In 2010, Inspect International in Germany has published an article on bin picking, and it's their 10th year anniversary, and they've actually talked about some of the history of bin picking. And publications like Sensor Review have also covered bin picking. So there's quite a bit of interest. Also some websites like robotics.org, which is the US-based industry association for robotics, called Robotic Industries Association. Their website is called robotics.org. That usually has good updates on bin picking.
Well, that's all the time we have for questions right now. Adil Shafi, thanks so much for your time and, more importantly, your expertise.
Thank you, James. It was a pleasure to be here and to work with you and your team, and I appreciate the opportunity to present at a Global Spec e-event. Thank you very much.
At the end of each session, I would ask you to please take a moment to complete the evaluation form that will appear on your screen. It's a good way to let our speakers know how they did today, and it provides us with the feedback that we need to help improve the quality of our Global Spec e-events as we strive to make them an even better investment of your time. And you know, you can stay up to speed every day with information delivered right to your inbox, because Global Spec offers more than 60 online publications filled with the latest advances in your area of expertise. Sign up for our e-newsletter and our product alerts to get the latest innovations to hit the market. You can find both of these links in the Resource Center under Global Spec Resources, and then click on General. And please join me again at 3 o'clock Eastern Time, when we'll be joined by Tom Napier from PSI Engineering. He has the perfect solution for an error-free supply chain. Also, Arlen Keck with Steel King Industries will be joining us to explore all the storage possibilities for efficient material handling. In the meantime, take this opportunity to explore the environment. Visit the vendor booths in the exhibit hall or meet presenters and colleagues in the networking lounge. We'll alert you via our scrolling marquee at the bottom of your screen about 5 minutes prior to the start of this next presentation, so you won't miss it. And we'll look to see you back here in the conference center at 3 o'clock Eastern Time.